rule. AS3000. So this is AS3000 rule. So AS3000, table C1, C2, C3 have to utilize. Then we refer the AS3000 rule and then we solve that one problem. Okay, this problem, we solved this problem. Determine the maximum demand of the single domestic electrical installation supply at the single phase. So it included 24 lighting point and 10 meter lighting track and a full number of the 10 ampere single socket outlet, 8 number of the 10 ampere double socket outlet, 1 number of 50 watt exhaust fan, 1 number of 1000 watt switch heater, 1 number of the 15 ampere socket outlet, 1 number of 10 kilowatt range, and 1 number of 4.8 kilowatt water heater, 1 number of 3 kilowatts are telescope lighting. So those are the kind of the electrical loads are provided. So based on the those electrical load, we need to calculate the maximum demand. So the maximum demand calculation, we had to utilize the AS3000. So this is AS3000 table C1. Table C1 is located at the phase 464. This is the table C1. So firstly, we have to see this which loads are utilized. So this is for the consumer installation. So this consumer installation is a single domestic electrical installation. So the tables are C1. You look at which one is a tables are C1. This is a table C1. So here is column 2 is a single domestic electrical installation. Column 2, 3, 4 are block raven unit. 2 to 5, 5 to 20, 21 or more to a block raven. So in this case, this problem is given the single domestic electrical installation. Therefore, we have to refer the column 2. So column 2, you have to refer it. And then you have to see the how many are light point. So light points are here. Firstly, we call the 24 lighting point. 24 lighting point is low group B1. You see the 24 lighting point. This is the low group B1. Socket outlet. So this is for the lighting asset. So low groups are A1. Lighting asset. So in this case of 1 to 20 point, you have to take the 3 ampere. So additional every 20 point increase, you have to add the 2 ampere. So this is for this rule. Because all the 24 lighting points at this rule, we have to refer this low group A1. So their rule is 1 to 20 point, we take the 3 ampere. So additional additional every 20 point, you have to add the 2 ampere. So that this problem is given the 24 lighting point. 24 lighting, because of 24 lighting point, first 20 point, we take the 3 ampere. So additional 4 point. Additional 4 point within the 20, so you got the 2, you add the 2 ampere. So this is the total current will be the lighting point is so here the calculation 24 point. So this is the lighting point. Another thing is also we find the 10 meters lighting track. So it is also given the 10 meters lighting track. So what is a lighting track? Lighting track is you see the lighting track here. Lighting track lighting track is a low group G1. No, this is the you see the lighting track. The group we look at here. So 10 MBR lighting track is here, load to A1. So below 4 and 6, so you see the 4 and 6 here. Lighting track is a 2 points per meter of track. Because all this are load to A1. Load to A1 is, you can see the below 4 and 6. Below 4 and 6 is the full node 4. Full node 4 is a lighting track. And 6 is a calculation incandescent length. So the also the lighting track is a every 1 meter is equivalent to the 2 point. So this is the lighting track calculation. So this problem, lighting track is 10 meter lighting track. So therefore the 10 meter multiplied with 2. So there will be 20 point. So this is the lighting track. In the meantime, we also this problem, you can see the exhaust fan. 50 watt exhaust fan. This is also the group A1. So that when you look at the group A1 is also we can see about the node. This node is 4 and 6. 4 and 6 is this is the 4 and 6. So this is 4 is a lighting track. What about the full node 6? The full node 6 is here. Full node 6 is a incandescent length up to 60 watt. So any incandescent length, we can take the 60 watt or the fluorescent length, and also others are power. Other power, so less than the 60 watt. So that any left holder, any power less than the 60 watt, we can also consider as a also the lighting point. So that this problem is given the 50 watt exhaust fan. So this 50 watt exhaust fan is their power is also less than the 60 watt. So this 50 watt exhaust fan also regarded as a light point. So that what are the light point now? They are the 24 lighting point, also the 10 meter lighting track, also the 50 watts exhaust fan. So there are 3 kinds of the light point. One is a 24 lighting point, now it's a 10 meter lighting track, and also 50 watt exhaust fan, equivalent light point. So therefore the 24 lighting point is we can count the 24 number of lighting point, and 10 meter lighting point track is every 1 meter equivalent to 2 points, so 2 multiplied 10, and also the exhaust fan is a 50 watts. So this is also we can regard as a light. So they are point are how many? 24 plus 2 multiplied 10 plus 1, so there will be 45. So they are 45 points. So therefore because of the 45 points, we have to count the low group A1. So low group A1 is there will be there's how many points. So every 20 points you have to count the 3 ampere. And so that 45 is equivalent to the 20 plus 5. So the first 20 point, 3 ampere. Second 20 point, 2 ampere. And then additional 5 point also we call it, we add the 3 ampere, 2 ampere. So therefore the how many current, how much current there will be? No. First 20 point is a 3 ampere. Second 20 point is a 3 ampere. And finals 1 point is a 1. So this is a 45 ampere. So this is the way we calculate it. So maximum demand is 45 ampere. Okay, this is the things how we calculate how we calculate the maximum demand. The second one is that we also the 10 ampere socket outlet. 10 ampere single socket outlet. Now 8 number 10 ampere double socket outlet. So the 9 number 10 ampere socket outlet we count the 9. 8 ampere 10 ampere double socket outlet, so 8 multiplied 2. So there will be 16. So this is there will be the 25 socket outlet. So how to calculate the socket outlet? Socket outlet is low group P1. First 20 point we take the 10 ampere. So another additional 20 point we take this 5 ampere. So this is the low group P1. Low group B1, this is the low group B1 root here. First 20 point, you take the 10 ampere. Another additional 20 point, you have to take the 5 ampere. So therefore, the total socket outlet is 25. So the first 25 is we take this first 20 point, we take the 10 ampere, additional 5 point, we got the 5 ampere. So there we get 15 ampere. In the meantime, you also see the 1 about 1000 watts of straight heater. 1 about 1000 watts straight heater is low group B, no? Low group C. So this is straight heater. So straight heater, so this is for the straight heater. So this will be the straight heater is similar to the instantaneous water heater. So instantaneous water heater is we can see the Hobbes rule of the instantaneous water heater. So instantaneous water heater here, this is a 33.3% of the connected load because the load group is E. Instantaneous water heater is similar to straight heater. This is the load group E. So we take the 33.3% of the connected load. So 33.3% of the connected load we calculate that. So the 1000 watts, so 1000 multiplied 33.3, so multiply 0.333. So you got the watt. So this is divided by the current voltage at 240. So you got the 1.387 ampere. So this is for the 1000 watts of straight heater we calculated. In the meantime, we also got the one number of 15 ampere socket outlet. So log 15 ampere socket outlet is a load group B2. You see the load group B2 here, socket outlet. So in this case, any socket outlet, any saturation, we have to take the 10 ampere. So therefore, for the 15 ampere socket outlet, we take the 10 ampere. Another thing is a 10 kilowatts electric range. 10 kilowatt electric range is load group C. So this is the load group C. 10 kilowatt electric range load group C. So electric range is we have to take the 50% of the connected load. So 50% of the connected load here, we calculate that 50% of connected load is 10 kilowatt range. So this is the multiply 50%. So the 10 multiplied 10 power 3 multiplied with 0.5 and divided by 240. Then we calculate the current. So this is the way we calculate the electric range current. So electric range current is 20.8 ampere. Then you also see the 4.8 kilowatts water heater. So here we also given the 4.8 kilowatts water heater. One about 4.8 kilowatt water heater. So this is a load group F. So a load group F here, water heater. Water heater, you have to take the full current. So the 4.8 kilowatt, we take the full current. 4.8 multiplied 10 power 3. So this is what? And divided by 240, you got the current is at 20 ampere. So this load group is, the current is a draw is at 20 ampere. And finally, it also given the 3 kilowatt standard scope lighting. 3 kilowatt standard scope lighting is a load group A2 because load group A2 is here. This is the outdoor lighting. Outdoor lighting. So exceeding 1000 watt. So in this case, we have to take the 75% of the connected load. So 75% of connected load is load groups are A2 got this standard scope lighting. So that will be the 3 kilowatt, 3 multiplied 1000, 75% of multiplied 0.75. So you got the power divided by 240 volt, you got a 9.4 ampere. So then you have to add everything. So that will be the, from here, all the lighting point is a 7 ampere. And also the socket outlet, 10 ampere socket light, 15 ampere. Instantaneous water heater 1.387, 15 ampere socket outlet 10 ampere. And electric range at 20.8 ampere. And 4.8 kilowatts of water heater 20 ampere. And also tennis scope lighting 9.4. You add everything, you got that at 83.5. So this is the way we calculate the maximum demand. So this is the way we calculate the maximum demand. So this is for the electrical engineer practice. We calculate the maximum demand calculation. Then we also do this electrical engineer trade practice. So electrical engineer trade practice 1. So trade practice 1. So there will be the page number 94.